Imagine that Bob snitches on Jane, and also that Jane snitches on Bob. If this happens, then we'll sentence both of them to 10 years, right? So if Bob snitches on Jane and Jane snitches on Bob, well, we then see, well, you know, they both tried to enter into rob the store or rob this grocery store. I forget what the example was. And when questioned about their participation in this act, Bob said, hey, Jane was there, she did it. And Jane said, hey, Bob was there, Bob did it. It was Bob's plan, it was Jane's plan, and so on. If they both snitch on each other, then they both collectively get, Bob gets 10 years prison sentence, and Jane gets 10 years prison sentence. Okay. Imagine that Bob snitches on Jane, but Jane doesn't say anything, right? So Jane says nothing, and Bob snitches on Jane. The question then is, well, how do we make an assessment of this, right? So Jane cooperates, Bob doesn't. Well, what ends up happening is it's going to make it seem that it's all Jane's fault, right? Because Jane doesn't say anything at all. She cooperates. Bob snitches on her. It makes it seem like she's accepting this blame. Bob said that you did it. You have nothing to say. Obviously, she doesn't know Bob said this. So she's going to get the maximum punishment, right? So what's going to end up happening anytime you have one party defect and the other party cooperate, the party that defects is going to receive no punishment at all, right? So Bob's not going to be punished. He's not going to receive any years in prison. But Jane, because she cooperated and Bob snitched on her, she's going to receive the maximum penalty, right, which is 20 years. Okay? And again, as I said, these numbers, you can use 5 and 3, 8 and 10, it doesn't really matter. The ratios matter, and I'll tell you how to come about the ratios after we finish playing the game. Okay. Now, obviously, these two scenarios are exactly the same. It's just inverse. Imagine now that Jane snitches on Bob, but Bob says nothing, right? So Jane snitches on Bob. Bob says nothing. It's going to make it seem as though Bob is guilty, right? When I asked Jane something, Jane said that you masterminded the whole thing. When I asked you something, you didn't say anything at all. It makes it seem as though you masterminded the whole thing. You're going to receive the maximum punishment. She's going to walk away. So the person who defects in this gets 0. The person who cooperates gets the maximum punishment of 20. Okay. And then lastly, what if they both cooperate, right? What if neither of them say anything? What if, you can imagine, Bob and Jane attempt to rob this grocery store, and prior to getting snagged, they said, listen, if the cops come, don't say anything, right? Just be quiet. We'll both be quiet. We won't say anything, right? Now, they don't know what the other person's going to say. Well, if Bob says nothing and Jane says nothing, then there's no way to really prove it. They get a very light sentence, right? They get not as light as 0, but let's say they each get 1 year, right? Definitely not as bad as 2 years. Now we've filled out all the numerical values for the game, right? Bob snitches on Jane, Jane snitches on Bob, they both get 10 years. Bob snitches on Jane, Jane doesn't say anything, Bob goes free, Jane gets 20 years. Bob says nothing, Jane snitches on Bob, Jane gets nothing, Bob gets 20 years. They both cooperate, neither of them snitch on either of them. Bob gets 1 year, Jane gets 1 year. So this is the construction of the prisoner's dilemma. Typically, this is where most people who do a construction, in most places that I've read the construction of the prisoner's dilemma, they stop at this point. But that's not a good place to stop, because now you can't understand sort of the logic of the game, right? If you stop at this point, you can sort of have an understanding of how punishment is assessed based on collective action or collective cooperation to an extent. But now we're missing all of these other variables, right? So what we've done so far is we've used D and C, right? We still have 4 variables left to use: reward, succor, punishment, and temptation. And now is when we plug in these final variables. Okay, so the 5th thing to do now is to use remaining variables, use the remaining variables R, S, P, T. Okay? So we need to use these last remaining variables and plug these variables into the fully recognized Prisoner's Dilemma game. Okay, now this is something that you'll just have to commit to memory, right? There's a lot of explanation behind it. I don't have time to really go into the level of explanation of which variables go where. I'll try and make the best sense of it, given the very limited time constraints of making YouTube videos, right? If both of them defect, right, if both parties defect, then we say that both parties will be punished. So we label two defections as punishment. So anytime we see two defections, we insert P. So we'll put P here, and we put P here. Anytime both parties defect, we label that action, two defections, as punishment. And they're being punished basically for ratting out the other guy. Okay. The next thing is where we see one defection and one cooperation, we need two different symbols for this, right? The person who defected succumbed to temptation, right? So whoever defects succumbs to temptation. So anytime we see a 0 in the game, we put the letter T next to it because that person succumbed to temptation. Whoever cooperated while the other person defected, this person's labeled a sucker, right? You're a sucker for having being quiet. You should have ratted out the other guy, is basically what it is. So anytime we see a C across from a 20-year sentence across from no sentence, the person with the higher sentence gets an S for sucker. The person with no sentence gets a T for temptation. So we put a T here, right? And then obviously we see that there's a T here across from a 20, so we put a T here as well. Here we have the 20-year sentence across from a 20-year sentence. This person's a sucker, right? You end up serving the maximum time. He ended up serving no time, or she ended up serving no time. So you're a sucker, you get an S. Okay? So we've used our S, we've used our T, we've used our P, and the only thing we have left is R, is reward, right? So the final thing is we put R at the bottom, and you get a reward for cooperating, right? There's a reward. Your sentence is less for your cooperation. Now this is almost the fully realized prisoner's dilemma. There's still one last thing that we need to do. We've used all of our variables. We've used R for reward. We've used S for sucker. We've used D for defect, or snitching. We've used C for cooperate. We've used P for punishment and T for temptation. We have all our three columns, the response of the participant or the party. We have the prison sentence that they got, and then we've assessed what this means, right? All right. Now what we have to ask is we need to try and figure out which is the best response, right? And which is the worst response. Which response has the highest prison year sentence, and then decreasingly which response has the lowest prison year sentence. The easiest way to go about doing this without having to try and sort of rationalize all of this is simply to look at the numbers, right? What's the highest number that we have as far as prison year sentence? And that's the worst response. Well, the highest number that we have is 20, right? 20 is the highest, is the most amount of years that you can be sentenced to prison. And then what we do is we look at the label next to that number. So what I do is I'll get another color. I draw a box around that label.